Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Calculus series and concerns what is integration. This guide introduces the concept of integration of a function as an area and as the inverse of differentiation. It tells you about definite and indefinite integrals and the constant of integration. Introduction. Calculus is one of the most important areas of mathematics. It was formalised by Sir Isaac Newton and Gottfried Leibniz in the 17th century, and they, working independently, related the two major fields of calculus, differentiation and integration. This study guide introduces the two types of integration, definite integration and indefinite integration. You will find that differentiation is taught before integration in almost all mathematical courses. This is because having a good knowledge of differentiation will help you to understand integration more easily. Therefore, before you learn integration, you should be able to differentiate basic functions comfortably. See study guides Differentiating y equals ax to the n and Differentiation of basic functions. Furthermore, before you learn about what integration is, you should first understand the concept of a function and its associated graph. See study guides Functions, Using Functions and Sketching a Graph. So, what is integration? There are two answers. 1. Integrating a function can give the area between the graph of that function and the x-axis. This type of integration is called definite integration. 2. Integration can be thought of as the inverse of differentiation. In the same way that subtraction can be thought of as undoing addition, integration undoes differentiation. This type of integration is called indefinite integration. This guide explains both of these ideas further, defines definite and indefinite integration, and explains the constant of integration. Methods and rules used to integrate functions of different types are explained in the study guides Integrating y equals ax to the n, Definite integrals, Integrating basic functions, Integration by parts, and Integration and natural logarithms, and in the fact sheet Standard integrals. Using integration to find an area under a graph. Being able to express an area as an integral and also calculating the area that an integral represents are both useful skills. In more advanced mathematics, you may have to calculate areas and volumes of complicated curves using double or triple integrals. So, practicing these skills on simpler integrals first is vital. When you integrate to find an area or region under a graph, you are performing definite integration, which results in a value for the area. The value you work out is called an integral and is written like this. The meaning of these symbols is explained in the following example. Example: express the shaded area in the graph below as a definite integral. The graph shows y equals x squared. And so the shaded area is enclosed by the x-axis, the graph of y equals x squared, the lower limit given by the line x equals 2, and the upper limit given by the line x equals 3. So the integral is written as this. This is the integration sign that tells you are integrating between the limits 2 and 3. The function you are interested in is x squared, and the dx relates to the fact that you are integrating with respect to x. In words, this notation means find the area enclosed by the graph of y equals x squared, the x-axis, and the limits x equals 2 and x equals 3. Looking at the meaning of the symbols in the integral in more detail, There are four parts of this notation that you should familiarise yourself with. The first part is the integral sign, this, which tells you that you are integrating. The second part is the function which you are integrating, f of x. This is also the graph you are finding the area under. In the above example, f of x equals x squared. This is known as the integrand. Part 3, the limits a and b. The values of a and b define the beginning and end of the region which you are trying to find the area of, moving from left to right. In mathematics, a is called the lower limit and b is known as the upper limit. A definite integral is called a definite integral because it is defined between the two limits a and b. They are written above and below the integral as like this. In this example, a equals 2 and b equals 3. Fourthly, the dx at the end. In integration, dx has exactly the same meaning as dx in differentiation, an infinitely small amount of x. It also serves to define the variable which you are integrating with respect to. For example, dx indicates integration with respect to the variable x, dt with respect to the variable t, and so on. You should ensure that every integral you write has an integral sign at the beginning and, for example, dx at the end. In general, a definite integral should always look like this, which can be interpreted to mean integrate the function f of x between a and b with respect to x. Or, in more detail, as find the area enclosed by the graph of y equals f of x, the x-axis, and the limits x equals a and x equals b. Example: integrate the function f of x equals 12 between the limits 0 and 3. Here, the function is f of x equals 12, and the limits are 0 and 3, and so the integral is written as this. Even though this guide does not give any rules for integration, you can evaluate this definite integral using geometry. The function f of x equals 12 is a horizontal line, see the study guide, the straight line, and the region described by the integration is shown as the shaded in the diagram below. As you can see, the definite integral describes a rectangle of height 12 and width 3. As the area of a rectangle is found by multiplying its width by its height, the area is 3 times 12, which equals 36. In terms of the definite integral, you can write the integral with respect to x of 12 between 0 and 3 equals 36. As this example shows, it is possible to use geometrical arguments to find the required area, and exactly the same answer will be given by evaluating the integral. If a geometrical argument is not possible, you will need to evaluate a definite integral. See study guide, definite integrals. Integration is the inverse of differentiation. In the previous section, you saw that definite integrals have the x values defined by limits and result in the calculation of an area. If the limits are not included, then an integral is known as indefinite. Integration of this type is the inverse operation of differentiation. Sometimes you will see an indefinite integral described as an antiderivative. But what does this mean? Take a function, f of x. If you differentiate it to get f dash of x, and then integrate the result, you return to f of x. Pictorially, start with y equals f of x. If you then differentiate, you get the derivative dy by dx equals f dash of x. If you integrate f dash of x, you return to f of x. You can just as easily say that differentiation is the inverse of integration. So, if you have a function f of x, integrate it and then differentiate it, the result is the function f of x. Start with y equals f of x, integrate to get the integral of y with respect to x, which equals the integral of f of x dx. If you differentiate this, you return to f of x. Example: given that the derivative of y equals x squared is dy by dx equals 2x, what is the integral of 2x dx? If you differentiate y equals x squared, you get dy by dx equals 2x. You can use the fact that integration is the inverse of differentiation to conclude that 2x must integrate to give x squared, and so the integral of 2x with respect to x equals x squared plus c. Notice that when performing an indefinite integral, you do not have any limits on the integral sign, but there is plus c at the end of your answer. Plus c is called the constant of integration and is explained later in this guide. When performing an indefinite integral, you can always check your answer by differentiating it. If you return to the function that you were integrating to begin with, then your answer is correct. Here, the derivative of y equals x squared plus c is dy by dx equals 2x, which is the function that you are integrating, and so the integration is correct. Example: what is the integral of dx? This is a very common integral, and it is useful to know and understand the answer. Firstly, the integral can be written in another, more useful form as the integral of dx equals the integral of 1 with respect to x. This is a case where it is useful to write the hidden 1. To help find the answer, you need to think of a function which differentiates to give 1. As the derivative of y equals x is dy by dx equals 1, the integral of 1 is x plus c, and you can write this mathematically as the integral of dx equals the integral of 1 multiplied by dx, which equals x plus c. The constant of integration. In each example of indefinite integration, you may have noticed that the answer has a number, c, added to it, where c is a constant, a number that does not have an x associated with it. This constant, c, is known as the constant of integration, but where does it come from? In the first example of the previous section, you were told that differentiating y equals x squared gives dy by dx equals 2x. However, this is not the only function which differentiates to give 2x. For example, y equals x squared plus 4 and y equals x squared minus 8 both differentiate to give 2x. As integration is the inverse of differentiation, if you are integrating 2x, then the answer is a function which differentiates to give 2x, as y equals x squared plus 4, and y equals x squared minus 8 all differentiate to give 2x. Which do you choose as your answer? In fact, you can add or subtract any number from x squared, and its derivative will be 2x. This is written mathematically as y equals x squared plus c, where c represents the addition or subtraction of any number. As a direct result of this, the answer to an indefinite integral also has the constant c added to it, to encompass all possible numbers which can be added or subtracted. You can calculate the value of c depending on the question you are answering. To do this, you need extra information called boundary conditions. Calculations involving boundary conditions are outside the scope of this guide, but a learning enhancement tutor can help you to understand these calculations. Summary. Definite integration gives an area between the limits on the integral sign, the curve and the x-axis. Indefinite integration is the opposite of differentiation and does not use limits, but you need to add c to the end of your answer. Further guidance and information. If you have any further questions about calculus or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. Telephone 01603 592761. Email dos.help@uea.ac.uk or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of calculus, mathematics, statistics and science available from the Dean of Students Office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills.